Hi everyone, we're going to find the value of c that makes each trinomial a perfect square. So basically for the first one, we're using a perfect square trinomial. All the lead coefficients here are 1. So you're just taking your second term here, your b term, even though there's an a. It's the one with the linear term. And you take half of it and square. So for this first one, I'll call this number 1, this number 2. We're going to take 12, divide it by 2, and square it. So that's going to be 6 squared, which equals 36. That means you'd have a squared plus 12a plus 36. And that means I can now write it as a plus take half of 12 is 6 squared. These are equivalent. These equal the same. All right, let's do the second one. So you take your negative 20, and recall that when you take the negative, it's going to square out. So this is going to be negative 10 squared equals 100. So now I can write this as h squared minus 20h plus 100. Which can be written as h minus take half of 20, 10 squared. These are equivalent. These are equivalent. So let's do the last two. We have 1 here. So you take negative 1, square it, and that gives you 1/4. So that means I can write this as p squared minus p plus 1/4. Now, that's equivalent now that if you condense it to p minus just take half of this, 1/2. Half of the 1 squared. These are equivalent. But your c is 1/4. And then for the last one, you take your 11, divide by 2, and then square it, which gives you 121 divided by 4. That's your c. So when I write it out, I would have m squared plus 11m plus 121 divided by 4. Once I have that, I can write it as m plus 11 divided by 2 squared, because they're perfect square trinomials. And that's it. Thank you. Have a nice day. Bye-bye.